Okay, now we'll just try to use some trigonometric identities that you have already studied in your previous year, and let me give those trigonometric identities. Or we'll just try to solve the problem as and when we require the trigonometric identities. We'll take up those trigonometric identities like sine 2x, cos 2x, sine 3x, tan 2x, tan 3x, all these values you have, all these formulas you already studied it. So using that, we'll try to solve few examples. So moving on to the next exercise, exercise 7.3. So find the integrals of the function. It's a common question. So let us start with the first one. Sine square, what is that term? 2x plus 5 it is. Sine square 2x plus 5. I need to integrate this one. So we'll try to find out these integrals. If you want to find out this particular integral, you can observe that this expression which is square term, and we don't have the direct integral for square term. So therefore what has to be done is we need to eliminate the square and write down the expression without the square term. So now the question is how to write down this without this square term. Now if you go for the standard formulas that you have learned in your previous year in trigonometry, you have studied this one. So for cos of 2x, we are having some standard formulas. I hope you have studied for cos of 2x or in terms of theta. So accordingly, I'll try to write down in terms of theta. Cos of 2 theta, there are three set of formulas. So the first one is cos square theta minus sine square theta. That's the first formula you have studied. The next formula that you have studied is 2 cos square theta minus of 1. One more formula that you have studied is 1 minus 2. It is 2 cos square theta minus 1. It is 1 minus 2, 1 minus 2 sine square theta. These are the three set of formulas for cos 2 theta itself. So now if you try to observe here in the question that we are having sine square. So where can you find sine square? This one. Here you are having sine square. However, here also you have square, but there are two squares here. Sine is also having square, cos is also having square. So I cannot take both these squares. I want only sine square. So because only one sine square is there. So I can take this formula and express this sine square in terms of without this square value. Therefore, I'll just try to rewrite this one. We know this formula. So out of three formulas, I'm only taking one formula. We know cos 2 theta. So cos 2 theta will be equals to how much? 1 minus 2 sine square of theta. But I want in terms of sine square, so it is better you can take this sine square on the other side. So if you take sine square on the other side, it becomes 2 sine square of theta is equals to 1 as it is. Send this cos 2 theta on the other side, becomes minus cos 2 theta. But if you try to observe sine square is not having any coefficient like 2, so you can send it on the other side. Sine square of theta will be 1 minus cos 2 theta, 1 minus of cos 2 theta, cross multiply, 2 will come. So what is happening over here is I'm just trying to eliminate this square and writing down the right hand side without any square term. So you need to remember this formula directly. Sine square of theta to be 1 minus cos 2 theta, right? Similarly, at this point itself, I'll try to give cos square theta also, so that for future problems I can use that one. So how to do that one? So this one. So what you're having? You're having cos 2 theta is equals to how much? 2 cos square theta, 2 cos square theta minus of 1. So send this minus 1 on this side, becomes plus 1. So 1 plus cos 2 theta will be equals to how much? It is 2 cos square of theta. Now since I want only cos square theta, it is better you try to cross multiply the 2 on the other side, becomes 1 plus cos 2 theta divided by 2 is equals to, you have cos square of theta. So hence I have got another formula, cos square of theta to be how much? 1 plus cos 2 theta divided by 2. So these two formulas you need to remember whenever you are trying to solve this type of problems. So the only difference that you can find in the case of sine square and cos square is this particular value, the sign. Here in this case it is minus, in this case it is plus. Rest other terms are the same. For sine square you're getting 1 minus, whereas for cos square you're getting 1 plus. That's the difference. So you need to remember this formula because in future we are going to use this formulas directly instead of deriving this one. So here I have derived it, but for rest of the problems I'll be taking it directly. Getting this one? So get back to this problem. So we have the sine square. So I'll just try to rewrite this one. So if you want to rewrite in place of theta, what I need to get here? In the question what you're having, it is 2x plus 5, right? 2x plus 5. Therefore, what I'll try to do is put theta is equals to 2x plus 5 so that I'll get back the question. So I am having sine square of theta. In place of theta, I have to write it as 2x plus 5 is equals to, on the right hand side, what will happen? So you're having sine square, theta is being replaced with 2x plus 5 is equals to, it is 1 minus cos 2 into theta value is 2x plus 5. 2x plus 5 whole divided by how much? Whole divided by 2. Whole divided by 2. Right? I have got the question back. Sine square 2x plus 5 he says is asking us to integrate. So before I integrate, let me once again simplify this one. I'll try to rewrite this 1 minus cos. Inside, let us try to multiply. So 2 times of 2 will become 4. 4x plus 2 times of 5 will give you 10. Whole divided by 2. Now let's try to integrate this one. Integrate. So if I try to integrate, I'll just put the integral as I is equals to integral of sine square. So I is equals to sine square 2x plus 5 into dx. So I'm integrating it. But we know the value of sine square 2x plus 5, it is what? 1 minus cos 4x plus 10, it is whole divided by 2. Whole divided by 2 into dx. But since there are two terms over here, one minus is there, it is better we try to split this one. This divided by 2, I'll take outside and apply the integral for this first term 1 into dx. So if you write down, it becomes integral of 1 into dx will be dx only, minus for the second term. Again integral of what you are having, it is cos of 4x plus 10. Cos of 4x plus 10 times of dx. So I have just applied integral for both the terms. Now let's try to integrate it. But if you want to integrate the second term which is there, 4x plus 10 is there, I have to use the substitution method over here. Therefore, let us try to put this 4x plus 10 to be equals to t. Let us try to differentiate this one. Differentiate 4 into x will become dx plus 10, it is a constant, its derivative will be 0 is equals to dt. Hence we have 4 dx will be equals to 4 dx is equals to dt. But here you don't have 4 dx, you have only dx. So therefore what has to be done is you have to just cross multiply this one. Dx will be equals to, it is dt, cross multiply that, it is divided by 4 will be getting. Now just put this value of dx to be dt by 4 back there in the given integral. So you have the integral I is equals to, it is half times of integral of dx. Integral of dx will be x minus, now it is integral of cos 4x plus 10 I have taken it as t, dx I have taken it as dt by 4. dt by 4. Since I'm integrating, I need to add the constant of integration. So this is nothing but half times of this x will remain as it is, minus this divided by 4 or 1 by 4 you can take outside and write down integral of cos of t into dt plus the constant c. So now if you try to simplify this one, this will be nothing but 1 by 2 times of, it is x minus 1 by 4, and integration of cos will give you sine of t plus the constant of integration c. But what is the value of t I have taken? I have taken the value of t to be 4x plus 10. T t is 4x plus 10. So it is half times of x minus 1 by 4 into, it is sine of 4x plus 10. 4x plus 10 plus the constant of integration c. So that will be the required solution.